Hello everyone, welcome to this video. In this video, we'll be talking about another question which is taken from IIT-JAM Mathematical Statistics question paper 2021. This is a 1-mark question and this is a numerical answer type question. So here they are asking if you are given this region A, right? This region, this 3-dimensional region in R cube is given to you with these limits, right? Then they are saying if alpha represents the value of this particular integral, then what is the value of 384 times of alpha? So this is the question over here, right? So in order to solve this, you should know what is this region, right? So in order to determine this region, so for the solution, we firstly have to see what is our region and how do we determine the limits here in this case. So we are given some point in R cube such that this point would lie in the region 0 less than equal to x, less than equal to y, less than equal to z, and this is all less than equal to 1. So if you visualize this region, let's draw our coordinate axis. Say this is the x-axis, this is y-axis, and this is z-axis, suppose, right? So say this is your x, this is y, and this is z, and this point is your origin. Now they are saying if we have 1 unit here on the x direction, 1 unit here on the y direction, 1 unit here on the z direction, so whatever is the area, when you join all of them, right? So whatever is this portion, that you would have all the points which lie from the point 0 to 1 in all the 3 axes, right? So everything which lies inside of this, that would be a part of your given region. Now you are to determine the limits here in this case. How would you do that? So here we have a simple trick, right? What is that? So we are to determine this triple integration over this given area, given region A, right? And we are to solve the this triple integration of x, y, z, dx, dy, dz, right? So here you either you could take out this limits and then proceed likewise. For that you should know what is the this equation of the surface, right? Or you could simply look here. In this case, what we can do, we can take the limits like this. Firstly we'll take these limits, then we can take these limits, and finally we can take these limits, right? So this is how we will proceed here in this question. So for that, for limits, let me write down. For limits, firstly, you know, x, because x is less than equal to y, so we have this first inequality here. So from here you obtain that x is lying from 0 to y, right? So this could be the variable limit for x. Next you can take the next limit 0, x, y, and z, right? Here in this case we will not consider x because now we are only interested to see what is the limit of y. So y here in this case would vary from 0 to z. So you would obtain the variable limits. So these are the variable limits for the variable y. This is the variable limit for x, right? And in the third case, if you take all of this inequality, now in this case we have the limits of x with us, we have the limits of y with us. Now we wanted to have the limits of z. So from here if you skip these two terms, why? Because we are only interested to see what is the limit of z. So in this case you see you have z varying from 0 to 1. So in this case we have constant limit for z, right? So now you have the limit according to this inequality. Then we can very easily solve our question, right? So here in this case, this area, this integration, triple integration of x, y, z, dx, dy, dz, that would be equal to, moreover you see you have you wanted to firstly solve this integration dx. So that means firstly here you have to write the limits of x. You know x varies from 0 to y, right? So you could substitute the limits here from 0 to y. The integrand would be as such, xyz, dx would be as such. Next is we wanted to perform the integration with respect to y. So here we would write the limits of y. What are those? It is 0 to z, right? So we will now write 0 to z. Now it would be obvious that whatever you solve here would come out in terms of y and z only, and the next you would, whatever you solve for y, that would come out in terms of z, and finally you would have the limits for z, right? What would be those? They are the constant limits from 0 to 1. So this is all you need to know for this question. Now the integration is very simple, right? For the integration, we'll firstly solve this much portion. For that, let's copy down the limits for z and y. That is, y varies from 0 to z. Now the integration with respect to x of x, y, z. So that means we'll keep y and z as such, right? As constant. So it would be x square by 2 y z, x square by 2 y z. So here we'll substitute the limits of x varying from 0 to y, dy dz. So let's solve this one. So z varying from 0 to 1, y varying from 0 to z, right? Now in place of x we have to write firstly y. So it would be y square multiplied with y, that would be y cube z divided by 2 for the first term, and for the second term it would simply be 0, right? dy dz. So this is after performing the integration of first term. Now we have to perform the integration with respect to y. So that means we'll treat this z as constant in this particular case. So let's copy down the limits for z. They are 0 to 1, right? The integration with respect to y. So integration of y cube is y to the power 4 divided by 4 and multiplied by z by 2 as such, because that is constant. And here we have to substitute the limits of y varying from 0 to z, dz as such. So in this case you will just write the limits here for z, and then we will be solving this. So when you, in place of y, substitute z, when you substitute the upper limit in this case, it would be z to the power 5 divided by 8, right? And when you substitute the lower limit, it would be 0 again, right? So this is what you have after solving integration, z varying from 0 to 1, z to the power 5 divided by 8 dz. Now that is simple for single integration. So how can you solve this one? You just simply have to integrate with respect to z. So that would be z to the power 6 divided by 6 into 8. And we have to substitute the limits, z varying from 0 to 1. So it is equal to 1 divided by 6 into 8 minus 0. So your answer is 1 into 6 into 1 divided by 6 into 8. And what is this thing? This is given to be alpha. This is given, right? So in this question they are asking what is the value of alpha. Then the value of 384 times of alpha, that is equal to 384 multiplied by 1 by alpha. So when you solve this, you see you could write 384 as 6 into 8 into 8 multiplied with 1 into 6 into 8. So you see why I have not multiplied 6 into 8 here for simpler calculations. So that is simply equal to 8 here. So here 8 is your final answer. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.